Hello everyone! In this video we're going to discuss some key concepts from chapter 10. We'll be looking at something called the one sample z-test, and we're going to learn how to compute it and then how to interpret the z-value and understand what it means. Many of my former students have told me that the concepts that they learned in this chapter really helped them to understand the concept of significance that we learned in the previous chapters. So I hope that you guys have the same experience. So let's look at when a researcher may want to use a one sample z-test. In a situation where a researcher wants to examine the difference between a sample and a population, and the sample scores are being compared to population scores, then it would be appropriate to use a one sample z-test. When using this type of statistical test, the researcher is only collecting data from one group, and that group is his or her sample. So let's look at an example where a professor is interested in finding out if her current stats class scored significantly different on exam 2 than all of her previous classes. In this example, her current students are the sample, and all of the previous stat students are going to be the population. So we would start off with step 1, where we state the null and the research hypotheses. Our null hypothesis will state that there's no significant difference between the sample and the population, and our research hypothesis will indicate that there is a difference. It's important to mention here that because our research hypothesis was non-directional, that means that it's what's called a two-tailed test. And this is important because in step 5, we're going to use the type of test, two-tailed test, to help us determine what's called our critical values. So that was step 1. For step 2, we'll go ahead and set the level of risk to 0.05. And then for step 3, we need to select the appropriate statistical test. So what statistical test are we going to be using to analyze our data? So using this chart, we can see that we have two choices as a starting point. On the left, we're asked if we're examining differences between one sample and the population. And over on the right, we're asked if we're examining relationships between variables or the difference between groups of one or more variables. In our example, we're looking for differences between the current class and comparing it to all previous classes. So we're working with one sample and making comparisons to the population. So we're going to use a one sample z-test. Next, the professor will need to find the mean for the current class and the mean for the previous classes, or the population, and the standard deviation, as well as the sample size and the population standard deviation. So this here is our available data, but you need to access the second video that I made to watch how to find the obtained value, which was 1.11. So when we computed the z-test using this information, our z-value was 1.11, which you can see in the other YouTube video. For step 5, we need to find the critical value, which I also showed you how to do in the other video. So if you haven't already, please check that out. With the z-test, you have two possible critical values, and they depend on your research hypothesis. If your research hypothesis was one-tailed or directional, then your critical value for the one sample z-test will be a positive or negative 1.65. Because our research hypothesis was non-directional, it's a two-tailed test, and our critical value is plus or minus 1.96. And I'll show you what that looks like in the next slide. In step 6, we are to compare our obtained value with our critical value. So our obtained value was 1.11. Obtained value is another way of saying our z-value in this example. So we're comparing our obtained z-value and the critical value of 1.96. And then we have to ask, which one is greater. The critical value is greater in this case. 1.96 is larger than 1.11. So that means that there were no significant differences in this example, and therefore the null hypothesis is going to be the most attractive explanation. So this is a visual representation of the normal curve and the critical value for the one sample z-test with a non-directional hypothesis. You can see where our critical values are on the normal curve. They are either negative 1.96, which falls to the left of the mean, and positive 1.96, which falls to the right of the mean. If our obtained values go beyond the critical values, then this is when we make the decision to reject the null hypothesis. Remember that the critical value is the point beyond which the obtained outcomes are judged to be so rare that the conclusion is that the obtained outcome is not due to chance, but due to some other factor. In this example, we define rare as having less than a 5% chance of occurring, and we have a 2.5% chance of finding an obtained value that exceeds negative 1.96, and a 2.5% chance of finding an obtained value that exceeds positive 1.96. When you add the 2.5% together, you get 5%, which, if you recall, was the level of risk we set in step 2. Let's say that we had chosen a one-tailed directional hypothesis instead. Let's say that we had said that the current stats class will have a significantly higher score on exam 2 compared to previous classes. Then instead of using a critical value of 1.96, we would instead use a critical value of positive 1.65. And it's positive because we indicated that our sample would have higher scores than the population. And that's what this would look like as a visual representation. This is the area of the curve beyond positive 1.65, and it represents a 5% chance of occurring. So I really hope that this video kind of helps you to better understand some of the concepts that we started learning in chapter 8 and chapter 9. And we'll go over this again, of course, in class and with our review sessions, but if you have any questions, please do not hesitate to reach out. I will see you guys soon.